Hello and welcome to a short video revising vectors in the Cartesian plane. So just reminding you that according to convention, I is the unit vector that runs parallel to the x-axis and j is the unit vector that runs parallel to the y-axis. Because they run parallel to their respective axes, they are of course perpendicular to one another. Okay, and we say unit vector because they're said to be one in length, which makes it easy for representing a vector in the Cartesian plane, because we can represent the vector r as 4i plus 3j by placing the vectors nose to tail to show where that puts us on the Cartesian plane. Now, as you can see, this produces a lovely little right angle triangle for us. We can do all kinds of analysis on it. One of the things we like to know is the scalar magnitude of that resolution vector. So in order to solve that, we use Pythagoras' theorem. Now we know I and j are 1 in length, so they drop out of our formula. And so what we end up with is a triangle with a base of 4 and a height of 3. So we use Pythagoras' theorem to work out the length of the hypotenuse. And so the formula for the modulus, or the magnitude of that scale, the scalar of that vector, is the square root of 4 squared plus 3 squared, which we can solve, of course, to the square root of 16 plus 9, which of course leaves us with an answer of 5. Okay, so what else can we work out? Well, we could also work out the angle between our resolution vector and the horizontal. So in this case, we'll label it theta. Once we've labelled it theta, we can use trigonometry by labelling the 3j, or the blue arrow there, 3 as the opposite, and 4 as the adjacent, and so tan being opposite over adjacent, we can write that tan theta is equal to 3 over 4. Okay, now of course solving this equation, we take the inverse tan of both sides, leaving us with theta is equal to the inverse tan of 3 over 4, which once we solve, we get that theta is equal to 36.9 degrees. Thank you very much for your time. I hope that gives you a short, quick revision on unit vectors and in the Cartesian plane.